Video lesson 6.4. This is the ratio method. So again, just to think back in a minute what we are discussing, and that was dilations and how to construct them, to just kind of take a step back and remind ourselves what a dilation is. That is the proportional enlargement or reduction of the figure by a scale factor. So in the previous video, when we were doing this, we were enlarging and reducing, and the point of dilation was on the figure. So the ratio method allows us to do that when we're not on there. Okay, we're not on the point of. I'm sorry, the point of dilation is not on the figure. So for example one, I'm going to split my screen here so that we can actually do the steps and the construction, so you can see both things as we do it. So this allows us to, figure out what these steps are, and then we'll provide them inside the diagram, the actual construction. So step number one is we're going to draw a ray or a line segment that begins at the center of dilation, so in this case O, and we're going to go through the figure. So in my figure here, again, using your straight edge, I'm going to use the line tool, but you guys are going to use your straight edge. We're going to go from O through A. Now we know in this particular example that this enlargement is happening, and aka we're getting bigger because the R value is 2. Specifically, it's getting double the size. So that line segment can be drawn through A and past it. We don't know how far, but we do know it's going to be past it. I want to do this. I want to draw this line segment through each one of these points. So again, as accurately as you can, we're going to draw a line segment from the center of O through each one of these points, A, B, and C. Again, I want to try and make this as accurate as possible. Just going to fix B here. There we go. So that's our line segments for each of them. So now we're going to use our compass here, and we're going to actually dilate this. So we're going to take our compass here. And again, we are dealing with an enlargement. So because the R value is bigger than 1, so we're dealing with an enlargement. We're going to measure the line segment and duplicate that however many times we need. So in this case, for our example, we need it to be double the size. So we're going to measure from O to each of the points, and then we're going to duplicate that process. Again, if it was a reduction, we'd be bisecting line, which we're going to do in example number 2. And then just so that I can flip through the screen, the last thing is once we do that and we find all the new vertices, A prime, B prime, and C prime, we're going to simply just connect all of them, and that should be our new figure. All right, so let's do this one. So let's do this in a different color so it's easier to see. So I'm going to put my pointer on O. Again, center of O. I want to rotate this, and I want to put the the pencil on A. Again, as accurate as I possibly can. We make a little arc to show we've measured it. All right, so there's 1. I want 2. So I'm going to slide this down, put my pointer on the mark I just made, which is A. Make another arc. So that is now my new point, which is A prime, and that is the point that's double. Now, if I wanted to triple, I would have done another one and then made another arc and see where intersect the line, and then that would have been A prime instead. So however many times you need to do this to represent the R value is what you do. 2, 3, 4, 5, whatever they indicate for you to have to do. All right, just keep making arcs until you get to the number that you need. All right, let's repeat that process. Let's do it again. So again, from O to B. So I'm going to shrink this down to B. Make an arc to show I've measured it. Actually, as I do that, I'm realizing it's not that accurate. I'm not in the center of O here. So let's do that. There we go. That's better. Slide this down. Put my pointer at B where I have that mark. Make my second one. So again, this is 2. That's all we need to do. This is B prime. One last one. We're going to do that for O, from O to C. If you want to try this one on your own, feel free to pause the video. All right, we're going to get out there. Looks like actually my compass just makes it. you shouldn't have any problems, but mine just makes it. And that gives me point here, which is C prime. All right, so now that I have all of my primes, I now take my straight edge and we're going to connect all those dots. So I'm going to use my line tool here. So A prime, B prime, and C prime. This one's off a little bit. Let's just adjust that. Again, we want to make this as accurate as you possibly can. That's better. And as you can see, it is an exact same figure that we started with. The only difference is it's larger, right? I recommend shading in your figures after you construct them. So I just think it makes it easier to see, especially if you're questioning whether you did something right or not. I do think there's a lot of times there's a lot of line segments that get kind of added in here. So I just think it works if you just kind of shade it a little bit. Kind of makes it pop out a little bit easier for you to kind of see what's going on, that you did everything correctly. You don't need to do this next part, but just again, as a visual check, these corresponding line segments should be parallel to each other. So as you can see, all of these sides that match up with each other, they should be parallel. So visually, you can kind of give yourself a look there to see, do they all look parallel to their respective sides? And they do. The other thing to remember about dilations is that the angles don't change. So whatever angle you have. So for example, angle B's angle measure is going to be exactly the same as angle B prime's angle measure. All right, so whatever it is, they have to be the same. All right, so that's the enlargement. Let's go to example number 2 here. I'm going to go back to a single screen, make this one a little bit bigger, easier to see now that we're not needing the steps. All right, so for this one, again, that first step was to draw those line segments. In this case, since I'm indicated here, it tells me, let's see, R was 2. I'm sorry, R was a half, I'm sorry. Where previous one was R was 2. I'm no longer getting bigger, now I'm reducing it, right? So this is a reduction. So I'm going to take my line segment, and I'm going to take your straight edge. I don't have to go through point S. I only have to go at least to it. Again, if you drew it through it, it's fine. But I only got to go to it because we know we're getting smaller. So again, reductions, the line segments come towards the point of dilation, and in enlargements, they go away from it. All right. Again, you need to be as accurate as you possibly can. So I'm just going to adjust here since I'm just using the line tool and not an actual straight edge. You guys should be better off than I am. All right, so now we're going to construct this. So again, we're going half. That's a bisector. Specifically, a perpendicular bisector is what we're going for, right? This is going to get a little crowded in the diagram here, so I recommend I'm going to do each one in a separate color. So this first one here, I'm going to take this, and I'm going to use red to show. So again, perpendicular bisector, I go more than halfway. So here's about halfway, right? I don't have to go all the way to S. I just got to go more than halfway. Make an arc above it, or on one side of the line. Make an arc on the other side of the line. Right? Then we're going to flip and do the same thing from the other endpoint, which in this case is S. Flip it around here, make an arc. Oops, that's not accurate. There we go. And do the same thing on the bottom. Where those two things intersect, I'm now going to take my straight edge, and I'm going to do this as a dotted line on the screen here because, again, I don't have to draw this line segment, this dotted line. I just need to see where it intersects. And actually, I really don't recommend drawing the entire line segment because, again, it gets very crowded. So just mark where it is, right? And then you can put a point. So like if I basically take that away, that's all you're going to see now. This way you don't have to worry about it. It makes it less crowded in the end, right? And that's now S prime. And I'm going to duplicate this process for each one of these points. All right, remember, we don't change the size of the compass while we're working on moving one of the points, but now that I go to a new point, now I can. So Again, I'm now going to start. I'll do a different color, do it in green this time. From O, we're going to go more than halfway to J. Right? Again, you can even go past J, but as long as you go more than halfway, right? I'm going to make an arc above and below. Scroll this over to J, right? We're going to now spin it around and see where they intersect the two arcs we just made. Now, if that happens, like I have here, I just drew the arcs. They don't actually intersect. You can see I was too short on the first one. Simply just go back to the previous point. So in this case, O. Just make sure you're in the right spot. You're lined up with your arc that you made originally, and just extend that arc. That's all. No big deal. All right. So now I have an intersection. I can now take my straight edge. Again, I'm going to do is a dotted line here. Connect them. Show where they're intersecting. Right here. Oops, that's sloppy. Let's make that better here. There we go. Put a point, right, where they intersect, and this was J prime. Once again, if you just think of my dotted line as my straight edge, I can remove that now, and I have the two construction marks, the two intercepting arcs, I should say, and where it intersects the line segment. That's all you need. I don't have to draw the entire line segment. Okay, but you're more than welcome to. It just gets very messy. I find that it's, especially for students, it becomes harder to see everything because there's so much going on. So, all right, last one. If you want to, feel free to give this one a shot on your own and then check back after you pause the video, see if you did it correctly, or you can follow along. So again, more than halfway, make an arc above, make an arc below, flip it, do the same thing from the other side, from B. Arc above, arc below. All right, take my straight edge, connect my points, aka the two arcs intersecting. And again, I'm looking for where they cross, so they crossed right here. Put a dot. That is now B prime. So again, if I just remove, just for you guys to see, I can remove the dotted line part, and you can see it's a lot less crowded going on. At the end here, once I have all my points, I do need to take my straight edge and now connect the dots. Now this is a solid line because this is actually the sides of my figure. So S prime to J prime to B prime, and then B prime back to S prime. Again, being as accurate as possible here, so I'm just going to adjust that. There we go. And as I said before, I do recommend shading it in, right? In this case, I think it just makes it easier to see, especially with all the lines going on. All right, so there you go. And that is our new image, right? That is called the image, right? The original is called the pre-image, and that's how we get that construction. All right, last but not least, example number 3. By far the easiest version. This is really kind of the work backwards version of this question. They're given the image and the pre-image. Again, remember when talking about this, this is the pre-image. This is the image. So pre-image is the original, image is the new. And we want to find the center of dilation. We're looking for, right, we got to find the location of O. Where is the center of dilation? So if we think about it, right, all the first two examples, we went from the center of dilation, we drew a line through the point, or to the point or through it, and that is how we got our new points. So here we're going to work backwards. We're going to take our straight edge. I'm going to draw a line segment from one point. In this case, so I'm going to start with A prime. I'm going to start in the image. I'm going to draw it through A. And I know that somewhere on that line segment has to be my center of dilation, right? So I'm going to do it again. Do it from another pair of points. So B and B prime. I'm going to do that through. All right. So again, I got to be as accurate as I possibly can, right? You want to make this really sure that you go through everything perfectly. There we go. Now, technically, you only need 2 points here in order to do this. But if you do make any mistakes, I really strongly recommend doing